I'm going to be going over CBA 5. Okay, for those of you that did not pass CBA 5, meaning you got below a 70, there is going to be a retest. The problems are not going to be exactly the same, but they'll be pretty close to these right here. Okay, so let's get started with this. On question number 1, we have the stem and leaf plot shows the amount of time Lisa spent practicing the piano during the last 2 weeks. Lisa's piano practice times, stem, leaf. Here you have this, then you have that right there. Okay. For this question, first of all, I always want everybody to circle this part right here on the stem and leaf. This means 1/5. This slash right here is this right here. Okay? So 1/5 means 15. Okay? From here, it's always best, okay, just to write the numbers out normally. So you have 15, 15, 18. Then on this one, you'll have 20, 20, 25, 25, 28, 28. Always go back and check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then on this one, I have 30, 30, 34, 35, 38. Okay? The other thing, this stem and leaf, remember, it's about Lisa's piano practice times. Okay? So, this is the times she spent practicing during the last 2 weeks, the amount of time Lisa spent practicing during the last 2 weeks. Question, how many times did Lisa spend more than 25 minutes practicing the piano? Remember, always underline the question. We want to know how many times spend more than 25 minutes. More than 25 minutes. Okay? So from here, more than 25 minutes, it's going to be those right there. Okay? It's going to be 28, 28, 30, 30, 34, 35, 38. So you have 1, 2, 3, 4, 5, 6, 7 times she spent more than 25 minutes practicing the piano. Okay? Now, on this, like I've said, right now we're barely learning stem and leaf in 5th grade. So I want you to get into the habit of writing this out. Okay? 20, 20, and so on. Do that for the whole thing. Okay? From here, answer the question, more than 25 minutes. Some of you might have put letter C for your answer, but it says more than 25 minutes. 25 is not more than 25. That is equal. Okay? 25 is not more than 25. 25 is equal to 25. That's why I did not include these. Okay? That's how you get your answer A 7 times. Okay? Let's go on to the next one. Number 2. The table shows X values and Y values for a number pattern. So here are your X's. 5, 10, 25, 20. 5, 10, 15, 20. Your Y's, 15, 20, 25, 30. Question, which statement is true? So we want to know which one of these statements is true. From here, The pattern is multiplicative. The pattern So remember, right here, multiplicative and additive. This is when we were just wanting to know, how do you get from the x to the y? Okay? What is the pattern? On this, I told you, always start off with just trying to add. 5 plus what equals 15? 10. Now, if that's 10, make sure you put all of them 10, because this is going to be for a number pattern. It has to have the same pattern, the same rule all the way. So now we got to check. We already know 5 plus 5 plus 10 equals 15. Is 10 plus 10 20? Yes. Is 15 plus 10 25? Yes. Is 20 plus 10 30? Yes. Okay. So on this tells me that we are adding. And because I know that we are adding, automatically this answer and this answer are going to be out, because they say it's multiplication. We're not multiplying, we're adding. Okay. Next, we had to add 10 to the x to get the y. So the pattern is additive because the y values are 10 more than the corresponding x values. So these are 10 more than these. True. The pattern is additive because the y values are 5 more. Wait, 5 more? They're not 5 more, they're 10 more. We had to add 10. That's why that one is out. Our answer, H. Number 3, the combined perimeter of the trapezoid and square is 54 inches. The model shows the dimensions of the trapezoid. What is the length in inches of one side of the square? Okay, so underline your question. What is the length in inches of one side of the square? So we're looking for the length of one side of the square. Okay, so we only want one of these. Here's my square, and here's my trapezoid. Okay, trapezoid. Now, let's go back. It says the combined perimeter of the trapezoid and square is 54 inches. Okay, what that means is this: combined perimeter. Combined perimeter. Combined means you put it together. The combined perimeter of the trapezoid and square is 54 inches. Perimeter. Remember, whenever we're talking about perimeter, I tell you to draw a little person, make the little person go all the way around. Perimeter always has to do with going all the way around something. Okay? So for perimeter with geometry, it's going all the way around a polygon. From here, it says of the trapezoid and square is 54 inches. So going all the way around is going to be 54 inches. Next, the model shows the dimensions of the trapezoid. So here are the dimensions. Okay? From here, they want to know the length of one square. Okay? This right here, the perimeter is 54, but that's for the trapezoid. That's for the trapezoid and the square. It's 54 inches. Okay? I'm going to be doing these strip diagrams. So the trapezoid and the square, the perimeter of the trapezoid and the perimeter of the square is 54. Remember, I've always said, whatever's in the boxes, you add, and it'll give you the number on top. Okay? From here, we know, or at least we can find out, the perimeter of the trapezoid, because here it is. So we'll do another little person, and we'll go around this right here. Okay? So the perimeter of the trapezoid is going to be 4 plus 8 plus 9 plus 5. We just go around the outside of the trapezoid. Okay? So that's 12, and this is 14. That's going to be 6. Remember, we're adding 2, so that's 26. So from here, I can go like this now. I know my trapezoid perimeter is 26 inches. The square, perimeter for my square, I still don't know. That's one I still don't know. I know that's a 54. In class, I've also taught you about this. Whenever you're missing a number on the inside, okay? To figure this out, you subtract these two. That's how you figure it out. For example, remember, numbers that are inside the boxes, you add them up. 2 plus 3 equals 5. If this one is missing, how can I get this number? I know what it is. I know that 2 plus 3 equals 5. However, how can I get it if I only have these two? Oh, I have to subtract. 5 minus 2, 3. Because remember, if this is addition, fact family, the operation that goes with addition is subtraction. Right here, if this one is missing, 5 take away 3, 2. See that? So I know that if I'm missing a number on the inside, I have to subtract the top with the inside number. So over here, I need to subtract 54 and 26. I'm subtracting 26 from 54 because I have this one missing. So I have 54 take away 26. Okay, from here I get 28. This is 28. Look, 28. Oh, but wait. One side is 28. What they're saying, the 28 is to go all the way around the square. The perimeter of the square is 28. The perimeter going all the way around. I don't need to go all the way around. I just want one of them. Also, remember, on a square, all the sides are equal. You have 4 equal sides. So you need to cut this 28 into 4 equal pieces. The operation that we use to cut something up evenly into pieces is division. The number that goes inside is always the number that's getting cut up. Separated, put into groups. Outside is the amount of groups you want or the size of each group. On this one, 4. So 28 divided by 4. 2 divided by 4, 0. 28 divided by 4, 7. So then each side is 7. So going back, the length of one side of the square is 7 inches. Okay? Now, let's go on to number 4. On number 4, Mark used 54 cubes to build the first layer of a rectangular prism. The edge length of each cube is 1 centimeter. The finished prism had a total of 6 layers. What is the volume of Mark's prism in cubic centimeters? So on this, step 1, remember, always underline. We want to know what is the volume of Mark's prism in cubic centimeters. So we're looking for the volume of the prism. Okay? So there's 2 formulas on your reference page on your recipe page. Remember, I also call it recipes. Okay, you have one that's V equals L length times width times height. And then there's another one that's V equals B, big B, H. This means the area of the base times the height. Let's go back. Mark used 54 cubes to build the first layer of a rectangular prism. So, 54 cubes, first layer of a rectangular prism. So if I have a rectangular prism, something like this, yes? Okay? My first layer down here, that's going to go all right here. That first layer, it's going to have 54 cubes, all the inside. So if I take this little top off, you're going to see the first layer, and it's going to have 54 cubes. Okay? All of this. There's nothing, there's all these little cubes in there. Okay? That's just the first layer. The edge of the length of each cube is 1 centimeter. The finished prism had a total of 6 layers. Well, if this first layer is 54, okay? Remember, that's going up, yes? It has 6 layers. 1, 2, 3, 4, 5, 6. So the first layer had 54. The second layer, 54. The third, 54, 54, 54. 1, 2, 3, 4, 5. And then this one is 54. Okay? We want to know what's the total volume. So actually, it would not be this one. It's sort of going to be this one. Okay? Where I know it's not the area of a base, but the base has 54 cubes and the height is 6. Okay? Height is 6. Okay? Layers. Think about a wedding cake. Wedding cakes, you might have 2 layers or 3 layers. That's what we're talking about. 2 layers means that the height is 2. 1, 2. 3 layers means that the height is 3. 1, 2, 3. Okay? So then you have 54 times 6. The 6 dances with the 4, 24. The 6 dances with the 5, 30 plus 2, 32. 324 cubic centimeters. Number 5. Paula graphed the point that is represented by the ordered pair 0, 4. In this ordered pair, what does the number 4 indicate? Okay, so underline the question. There you go. What does the number 4 indicate? Number 4, indicate. So what does that mean? That's what indicate means. What does the number 4 mean? What does the number 4 indicate? So we have this ordered pair, 0, 4, and they want to know what the 4 is. So little quick reminders on this. Okay, first of all, when we write our ordered pair, you have this, and then going back to what we did in class, in the alphabet, it's ABC dot 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 X, Y, Z. Okay, ABC dot 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 X, Y, Z. So this is your X and this is your Y. Next, when you do a graph, remember, the Y has that long tail coming down. So this is your Y, this is your X. Right here, that's your origin. Okay? After this, okay? Now we want to know what 0, 4 means. Okay? Now, the 0, that's on the X. Well, the numbers are going this way. okay, for the x-axis. As a refresher, let's look at this. Remember when we did this in class? Of course, the ladders weren't that tall. They only had, one of them had several steps, maybe like 4 steps, but all the other ones only had 2 steps, okay? This is ladder 0, ladder 1, ladder 2, ladder 3, okay? This is a little person, and if they tell the little person to go to the 3rd step on ladder 2, okay? That person has to go to ladder 2 and then go up to the 3rd step. 1, 2, 3. There's the 3rd step. You don't count this one. This is the ground. There are no steps on the ground for a ladder. No, there isn't. This is step 0, if anything, because there is no step. Step 1, step 2, step 3. If they tell a person to go to ladder 1, step 4, they start walking to ladder 1 and they go up to the 4th step. 1, 2, 3, 4. That would be this one. If they say go to ladder 0 and go to step 2, well, he's already here, so he just has to go up. 1, 2. See that? Okay. Now, how this works over here is, here's your ladder, here's your step. So, this is where you start. Just to help us out, sorry, messed that one up. This is our origin. 0, 0, 1, 2, 3, 4. 1, 2, 3, 4. So 0, 4 means ladder 0. These are your ladders. Ladder 0, ladder 1, ladder 2, ladder 3, ladder 4. And then you go up the steps. You don't go up the steps and then go this way because you'll fall. Okay? You cannot go to step 4 on ladder 3 by going up into the air and flying across. No, you always walk to the ladder first and then you go up. So over here, ladder 0, well, you're already here. Now you just have to go up 4. 1, 2, 3, 4. That's where it would be. So looking at this, it says the point is 4 units above 0 on the x-axis. No, it's on the y-axis, not the x-axis. Okay? Remember, ABC, XY. The point is 4 units above 0 on the y-axis. The point is 4 units above 0. So let's see. Above 0 on the y-axis, and this is y. Yes, that's it right there. Well, let's still check out the other ones. The point is 4 units to the right on the y-axis. Okay, first of all, we don't even go to the right. Okay? On the y-axis, and they even put that one. No, that's the x-axis, and we're not going to the right. The point is 4 units to the right. No, we don't go to the right. Okay? We just go up. Because 0 says we're at ladder 0, we're at point 0, and we just go up. Okay, so there's our answer. Number 6, which table represents the equation y equals 4x? Okay, so in other words, this is one of those, again, where it's either going to be additive or addition or multiplication. How do you get from here to here? Basically. But look, right here it says y equals 4x. We've already talked in class that whenever you have a 4 and a letter next to it, a variable, and there's no operation in between, that's going to be multiplication all the time. Okay? That's multiplication. We don't do this sign anymore for multiplication because we might confuse it with the letter x, the variable x. We don't do this one anymore because we might confuse it with the decimal. So what we wind up doing is we just put nothing in between, a number and a letter. This means that it's going to be multiplication. Okay? So we need to multiply. What are we going to multiply? 4 times x. These are your x's. So you need to multiply that by 4. Okay? We got to figure out which one of these will get us the correct one to the other side. Because it's saying that the y equals x times 4. Okay? Or 4x. So let me see. 3 times 4, is that 12? Yes. 4 times 4, 16? Yes. 5 times 4, 20? Yes. 6 times 4, 24? Yes. 2 times 4, 6? No. 4 times 4, 1? No. 2 times 4, 2? No. Our answer, F. Okay? On this one, this graphic organizer is being used to classify triangles based on their angle measures or side lengths. Triangles, angle measure classification, acute, right, obtuse, side length classification, scaling, isosceles, equilateral. Which list shows all the ways this triangle could be classified? So they want us to know all the ways triangle could be classified. Okay? On this one, let's go over some of the definitions first. Remember, on this, acute, this is when I was telling you, acute, a little angle, how cute, acute. Right, looks like an L, 90 degrees. Obtuse, when you go to the doctor and you feel sick, your throat, maybe you have a sore throat, they put a popsicle stick into your mouth, press down on the tongue, and they say, open up nice and wide and say, obtuse. So obtuse angle is a very wide angle. You have, how cute. The L is a right, obtuse. Okay? Next, side length classification. You have the scaling, isosceles, equilateral. So the scaling, okay, we'll do this. Isosceles, and equilateral. Just drawing, I'm just putting the first letter for those right there. There's a reason why I'm doing this. There's a reason to my madness, I always tell my students. Okay, so look, scaling. Better yet, let me start off with the equilateral. See how it has 3 that are dark? So an equilateral triangle has 3 sides that are congruent or the same. See the eye, how it has 2 really dark sides? Isosceles triangles have 2 sides that are congruent. What about this one? How many sides are dark? 0. A scalene has 0 sides that are congruent. From here, let me see. These lines, you have one line here, one line here. I've told you that means that this side and this side are the same. They're congruent. So how many sides do you have the same? 2 sides. 1, 2. This one has 2 stripes. They're different. This has 1, this has 2. They're different. This has 1, this has 2. These two are the same. This has 1, this has 1. So you have two sides that are the same. Okay? Next. Look at that angle right there. Okay? That's a right angle. From here, right and isosceles only. Okay? Sounds good. Right, isosceles. Acute right and isosceles only? No. If it's an acute triangle, that means all the angles have to be acute. That one's a right. Here's an acute. See that? A little angle. Aw, how cute. Acute. Little angle. Aw, how cute. Acute. Little angle. Aw, how cute. Acute. On an acute triangle, all the angles have to be acute. Right and scaling? Right? Yes. But scaling? No. Because look, it's an isosceles. These two sides are the same. Two sides that are the same, isosceles. Right? Isosceles and equilateral. Equilateral? No. Equilateral means that three sides are going to be the same. We have only two sides that are the same. Answer, A. 8. Matt is trying to graph the point 2, 6 on a coordinate grid. Starting at the origin, which movement should Matt do first? Okay. We're looking for which movement do we need to do first. So Matt is trying to graph the point 2, 6 on a coordinate grid. Okay, so trying to graph 2, 6 coordinate grid. Starting at the origin. That's really important. So on this, remember, 2, 6, ABC, dot, 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 X, Y, Z. Now, once again, ABC, dot, 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 X, Y, Z. Look at the Y. So on this, here's my Y-axis. Here's my X-axis. Okay, I'm just going to put a few numbers just to start it off. This is 0, 1, 2, 3, 0, 1, 2, 3. This is my origin, 0, 0. But your little person is right here at the origin. Okay? Now, it says, which movement should Matt do first? That's this one. Okay? X, Y. You always do the X first because X always comes first in the alphabet. So you have to go on the X axis. It's going to be 2. Here's my X axis. 2. Okay? Remember, also, if I write this down, 2, 6, X, Y, 2 is my ladder, 6 would be the step. This is my ladder. This is my step. Just another way of helping us understand how to plot these points. So then, 2, and then I'll go up 6. My first point is move up along the y-axis. Wait, move up? We're not moving up. We're moving this way. And it's not even the y-axis. It's the x-axis. Move right. Yes. On the x-axis. Yes. To number 2. Move right. Yes. Along the y-axis. That's not the y. Okay. And they said to 6. No. Okay? This is 2 on the x-axis. Move up. Wait, move up? We're not moving up. On the x-axis, no. X is this way. Remember, that's why the tail is very long. Move right along the x-axis to the number 2. That's our first step. Okay? Number 9. The table shows the outside temperature and the number of cups of hot chocolate sold at a diner for 6 days. So we have this outside temperature, X. All of this is outside temperature on the x-axis. The number of cups of hot chocolate sold, that's going to be on the y-axis. So all of those are for the y-axis, okay? So just to help us out a little bit better, okay, this is going to be for my X right there. And the Y will be this one right here. That's not colored, okay? From here, which scatter plot best represents the data in the table? So we're looking at a scatter plot best represents data from the table. So this has to go onto a scatter plot. Now, unfortunately, not all of them come out along with the top part, so I'm going to have to be going up and down. But this is the way I usually tell my students to do it anyways. Okay, so first of all, this is the X, this is a Y. Remember, A, B, C, X, Y, Z. My Y has to go up and down. Okay, so my X is going to go side to side. This is my X, X, X. From here, let's see, 34, 28. Okay, first of all, let's see what they're counting by. 20, 30. Right here, they're counting by tens. Here, they're counting by tens. Here, let me see, 34, 36, 38. Here, they're counting by twos. You see that? And I believe that's the way it is with all of them. Yes. Yes. Yes, just checking. Okay. Yes. Okay. This right here is a break in the graph. We'll learn that later on in middle school. Okay, about doing little breaks like that, because then the graph is going to be too big. So that's why they do that. Next, so at 34, there's going to be 28. So you go to 34, 28. Let's see, 34. That's about 28. Okay. Then, let's see if we get any of them out from here. Okay. We said at 34, you go up to 28. 34, that's about 28. 34, no, that's not 28. In between the 20 and the 30 is 25. 28 should be above that. That one's out. See that? At 34, 28. Okay, so far we have those two still in the race. On this one, at 36, we have, looks like 65. Okay, so at 36, we need 65. 36. No, that's not 65. That one's out. 36. 65. Wait a minute. No. 36, 65. 36. No. That one's out. 36, 65. I don't even have to look at the rest of them because these are already out for one reason or another. Okay? That's how I like my students to do it right there. Do one at a time. See if you can get some of them out. Okay? Number 10. The graph below shows the number of t-shirts sold at the store during the last 4 months. T-shirts sold. These are the months. Last 4 months. 1, 2, 3, 4. Number of t-shirts. These are the number of t-shirts. So we have t-shirts sold. The months. Number of t-shirts. Very important. Our key. This grayish is short sleeve. This black one is long sleeve. Now, if you don't know what short sleeve and long sleeve mean, it doesn't matter. All that matters is you know that this one means short sleeve and this means long sleeve. That's it. Based on the graph, how many more short sleeve shirts than long sleeve shirts were sold during these 4 months? So, underline your question. How many more? Look at there. How many more than? Remember, those are my key words right there. In the question, whenever the question has how many more than, how many less than, that means it's going to be comparing. The operation will always be subtraction for sure. You might have to do some other things, but for sure, you're subtracting. How many more than? You're comparing. And what is it that you're comparing? Short sleeve to long sleeve during the 4 months. Okay? So that's really important. So for sure, for right now, let's see, this March, we have 18 for this one. We have 12, 14, that's going to be 13. April, 10 and 12, that's going to be 11 because it's right in the middle. This one, 19. For this one, 22. For this one, 9. This one, 23. And this one, 7. Now, we're comparing the short sleeve versus the long sleeve. So on this, we're going to have short sleeve, long sleeve. We need to find out, first of all, how many short sleeves are there. That's going to be the gray ones. So you have 18, 11. Those are the ones that we want right there. Okay? We're going to want 18, 11, 22, and 23. We're going to add them up. We should have 4 numbers because there's 4 months. 18, 11, 22, 23. Those are the short sleeves. We add them up. 8 plus 2 is 10. 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7. 74. Long sleeve, it's going to be the numbers that are not circled. 13, 19, 9, and 7. Add them up. Okay, so this is 10. This is 18. And 10 is 28. 2, 3, 4, 48. Remember, how many more than? We're comparing. That means you have to subtract them. We're subtracting the 48 from the 74. From here, 26. There's our answer. Keyword, whenever the question has how many more than, how many less than, okay, you're comparing left to the right from the word than. Always subtract, always. When the question is having you compare, always subtract. Here's another one that unfortunately I cannot show all of it. So I'll just do it little by little. The aquarium measured the length of each fish in the fish tank. The table below shows the number of fish that measured different lengths. So length in inches. These are the lengths in inches. Number of fish. So which dot plot represents these measurements? We're looking for the dot plot. These are your dot plots right here. What this means is if a fish was half an inch, you only had one fish that was half an inch. 4 fish that were 1 inch. 2 fish that were 1.5. Just like before. Okay, we're going to go like this. Here are the lengths. Okay, those are the lengths. Those right there. Okay, for half an inch, that would be this right here. This would be a half because it's right in between 0 and 1. I'm supposed to have 1. I don't. That one's out because it's missing. 1 dot, great. Half an inch. 1 dot, great. Half an inch. Remember, all of these are half. Half an inch. No, way too many. See how I was able to get 2 of them out? Okay. At 1, you should have 4. At 1. Oh, sorry. I'm not even supposed to be looking at this one anymore. I'm not even supposed to be looking at that one. At 1, I should have 4. 1, 2, 3, 4. 1, 2, 3, 4. At 1.5, I'm supposed to have 2. This is 1.5. 2. 2. At 2, I'm supposed to have 3. At 2, 3. At 2, 3. At 2.5, 0. 2.5, 0. 2.5, 0. At 3 inches, 4. At 3 inches, 1, 2, 3, 4. Ooh, 1, 2, 3, 4, 5. 1, 2, 3, 4. So at 3 inches, I'm supposed to have 4. This one has 5. There's my answer. Okay. For the last one, 4 points are plotted on the coordinate grid below. Which table represents the data plotted in the graph? So, we want to know which of these tables goes with this right here. Okay? From here, remember, we're looking at plots, right? ABC, dot, 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 XYZ. Also, ABC, dot, 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 X, Y, Z. The Y is the one that goes up and down. The X goes side to side. We always do the X first. So let's just try to see, let's just get these plots first. I'm going to say this one's A, this one's B, this one's C, this one's D. So A is 1, 1. Remember, oops, sorry. I was thinking about something else. The ladder. That's what I was thinking about. Here's your 0. Okay. So you have to go to ladder 1, step 1. For B, ladder 3, step 2. For C, ladder 5, step 3. For D, ladder 7, step 4. So now we look. 1, 1, 1, 1, 1, 1, 1, 1. Yes. On this one, B, 3, 2, 3. Okay, that's supposed to be a 3 right there. See? Ladder 3, step 2. They have X2. No. No, 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 no. This one is wrong. That's supposed to be 3, 2, not 2, 3. 3, 2, not 2, 3. 3-2, not 3-3. There you go. See that? That's why I like to do it like that. And look, 5-3, 7-4. Okay? So on this, hopefully this has helped you out with this test. Okay? And remember, you will be doing a retest for those that got below a 70. The highest grade you can get on a retest is going to be a 70. If you get 100, I'll only put in there a 70. Okay?